me. I just moved here to Aquatopolis and came to see the aquaponic fountains. Do you know when the next tour starts?
Oh, the next tour doesn't start for another hour.
Is this a model of Aquatopolis?
This is a model of a section of the city with a scale of 1 inch equals 25 feet. Here is the aquaponic fountain that we are in right now.
Cool. I recognize the condo building in the residential area where I live. And there's a commercial zone down by the Guadalupe River where my husband likes to shop. And there's one of the theme park rides. Oh, and I recognize the industrial building where I work. Did you make this model?
Yes, I'm Dylan Samra, Chief Engineer of Aquatopolis. In order to promote a green environment, I made this model out of recycled materials. This building is made out of an old trophy, and this broken white-up room is conveniently the exact same shape as one of the buildings.
So, how do the aquaponic fountains work?
Well, water is pumped from the Guadalupe River into the fish tanks, where the fish excrete nutrients into the water. This nutrient-rich water is filtered to remove the solid fish waste, and then is used to grow plants hydroponically. The water is then pumped back to the Guadalupe River, completing the cycle.
What happens if the river dries up?
Well, the aquaponic fountain pump system is connected to an aquifer that can act as a backup water supply should the Guadalupe River dry up.
And what type of fish and plants do the aquaponic fountains produce?
Aquaponic fountains produce two main items, romaine lettuce and...
Me! Oh my gosh! What is that?
I'm the world's largest and smartest bluegill.
But how can he talk?
No one knows how he can talk. Once he starts, it's hard to get him to stop.
Bluegills like myself are run in these fountains. Every day, over 4,000 bluegills are produced from each 600,000 liter tank. So this means that one aquaponic fountain daily can produce up to 24,000 fresh fish, in addition to over 100,000 pounds of lettuce. The tanks are made of cartoon.
You mean the tank's made of carbon nanotubes, and the umbrella, which is used to keep rain and other things in the air from getting into fish tanks, are covered with transparent photovoltaic cells that provide energy for the fountains, making the system very green and self-sustaining.
Oh, carbon nanotubes. Well, I'm just a fish.
Although he's quite a nutritious fish, I must say.
Because the average bluegill has 21 grams of protein and only 1 gram of fat. Of course, I'm a little bit larger than that. And the romaine lettuce is full of vitamins K and A, fibers, and other minerals. These foods are very healthy while still being appealing to the citizens' appetite.
So, how'd you come up with this urban agriculture idea?
Years ago, as the city expanded, we had a problem finding enough room to grow all of the food needed by the citizens using large fields of crops and cattle. We used the engineering process to brainstorm ideas. We started with traditional aquaponics and then became even more efficient by going vertical and placing the plant beds directly on top of the fish tanks. After testing the system, we realized that it produced too many fish and not enough lettuce. Finally, we redesigned to reach a solution where the fish tanks were located above the plant beds, requiring fewer pumps and allowing for a flexible ratio of fish to plants. This innovative solution became known as the aquaponic fountain.
Can you grow crops year-round?
Yes, because during the winter, the umbrella deploys a transparent material over the fountain, creating a tent-like structure that produces a greenhouse effect, keeping the temperature warm.
But what happens before the fish get sick?
Well, that is one of the risks, but the aquaponic fountains are one bed of lettuce. So if the marine biologist microorganism sensors were to detect an infection in one of the tanks, then only 1/6 of the fountain would actually be affected.
To minimize additional risks, we employ a decentralized system of 60 aquaponic fountains across the city. This way, if something happens to one of the fountains, it doesn't have a major effect on the overall food supply.
This is a well-thought-out system. You must have some smart engineers.
We do. Electrical and mechanical engineers design the power and mechanical systems, with a key role with the civil engineers who design the overall aquaponic fountain.
Aquatics engineers who design the system that harvests and processes the bluegill and lettuce, and the drone delivery system that takes the food from the aquaponic fountain.
Aquaponic fountains must cost a fortune.
It costs a lot more than your average goldfish bowl. But if you consider how little space the fountains take up, and yet they can feed the entire city's population, then the trade-off is worth it.
Additional benefits of the aquaponic fountain is that they produce no carbon emissions at all, and they produce organic.
I do love bluegill, but there's a large variety of food in Aquatopolis. Where does the other food come from?
Well, the aquaponic fountains are designed to produce almost 2 times the amount of food needed by the citizens. The surplus is traded with other cities for different types of food that you enjoy.
I love living in Aquatopolis. I moved here because of the amazing education and learning tools offered by the city for my children, as well as engineering university. I also feel comfortable knowing that the police surveillance networks are preventing crime and are keeping the city safe.
And plus, the air is always pollution-free in Aquatopolis.
That's probably because all of the cars are electric, and the electricity is powered by solar cells on all of the buildings. And this city is so green, it's amazing. When I moved here, I got to trade my old car in for a new electric one, no extra cost. I also love how there's so many parks for me to visit with my friends.
And I love making new friends every day, since my old friends keep disappearing.
Thanks for showing me around. I guess I don't have to take the tour anymore. I am getting hungry now. Is there anything around here to eat?
Whoa, look at the time. I gotta swim.
Judges, you have a 5-minute Q&A session. The presentation left over, so 5.5 minutes.
Well done. Okay, first question. And it covers some of this, but what are the biggest challenges of large-scale urban farming?
Well, the biggest challenges of large-scale urban farming is being able to produce a large amount of food in a small amount of space. So we need to be able to produce enough food to feed everybody in the city and have room to be able to grow all that food for them. And so we're able to solve that problem by creating a vertical system, and so that we can produce more food in less amount of space by stacking it on top of it.
And then how do you set your budgets to meet the needs and desires of the citizenry, such as public services, infrastructure, recreation, and balance things?
Well, the food doesn't cost that much to produce. It's a very small amount of budget that's actually gone into production of food because of the way that we very efficiently grow our plankton in our protein. And so the rest of the budgeting plus the surplus that we make, since we produce 2 times the amount of food actually needed for our city, that surplus is traded and we have enough revenue and enough money to be able to pay for all our city services like our medical and our fire and our police services.
Since you've just mentioned the cost of production, how much does it cost per pound of bluegill and per pound of romaine lettuce to produce?
Alright, so we're able to produce the fish and lettuce for cheap because of economies of scale, since we have so much produced in our city. So we're able to produce romaine lettuce for 25 cents a head, and this is 1 head being a pound, and 1 bluegill provide 1 pound of fish. And so it costs 25 cents to grow lettuce and 50 cents to grow bluegill.
What factors went into your decision to locate your city where you did along the river?
We wanted to use somewhere that was very sunny, so Central Texas was a very good option. And since the river is very good to power our fountain with its water, or to use the water for our fountains, we wanted to be sort of centralized around the river so that we can use that resource.
And Central Texas, on top of being a very sunny climate, is very flat and it is on bedrock, making it more stable because we don't have to dig as deep underground. And this also allows for more expansion.
How did you delegate who was going to be doing the presentation on your team?
Well, we looked at, we started when we had our team, we looked at expertises, and so we split them up by there. So we had people doing computer, who are like doing computer stuff, they were computers, they worked on SimCity, the good writers worked on the presentation, or the essay narrative, and then people could art do the model. And so after that, we decided we needed to do the presentation, and so we looked at the 3 people with the best presenting skills and who could work well and talk in front of people, good drama. And so from there, we were able to choose the leaders.
And how many are on your team?
We have a team of 8. We have 6th graders, 7th graders, and 8th graders on the team.
So we're 8th graders and she's a 7th grader.
Okay. And have you been at the
mentioned the electric car. What other type of transportation infrastructure have you designed into your city?
We have electric buses for people that can't afford cars. So you can use the electric buses if you don't have a car or you don't have a car with you. Another thing we have is walking trails, which are all around our city because our city is very pretty to walk around. And if you live here and you work here, it's really easy to walk across a footbridge so you can get to work and you can enjoy the sun. And another mode of transportation is taxis, and they're self-driving, and so you have an app on your phone that connects to the taxi. So when you walk in, you audibly say where you want to go, and it will take you there and charge your phone, so you don't have to do any of that. And most of the cars are self-driving, so people with disabilities can get around just as easy as people without disabilities.
Our city is zoned around the aquaponic fountains. We have 60 around our city, and all of the utilities and all of the different zones are placed around each of these in 4 square kilometer areas, as well as little bike stations on the side of roads so that you can go take a bike, and that works the same with your phone as well.
What measures did you take to protect your city against natural disasters?
Well, we have a decentralized system of aquaponic fountains so that if there's a natural disaster, we can still provide food for the entire city. We also have carbon nanotube support structures that will help keep the buildings up from if there's a natural disaster. And then we also placed our city in a location where there's not really any earthquakes and hurricanes are not going to get that far inland, so we're able to prevent from having to be in an area with lots of natural disasters.
And not just our food production system, but we're placed on an electric grid for photovoltaics. So if one building were to get destroyed,